Rest, motion, time, distance, displacements, all these topics are there in class 7, 8, 9, 10, 11. Right? Now, all these topics are approached in a certain angle in lower classes and they build on and go on to the next classes. Now, my whole idea of doing these classes is not researching. I want to see things on the perspective of students. I want to go back to my student days. What is the problems that I faced while conceptualizing these notations or this phenomenon, and I try to go into the world of these kids, of you kids, and I strongly believe that you won't come to this world, to my world, adult world, and learn things from me. What I have to do is go into your world and then explain things in the perspective that you see it and change it and conceptualize it correctly. So this is the first class on physics in Have Fun. Yes, you are with Have Fun and Learn, and I'm JP Datta. This is our first class on physics. Today we'll pick up rest, motion, distance, displacement, time. Right? So let us see what we have in store for us. Yeah, so number 1, rest. Number 2, motion. Number 3, distance. Number 4, displacement. Yeah, these are the 4 topics we are going to discuss today. Now, we'll pick up first rest, and then as you go on, we will see what we have in store for these rest of the 3 topics. Now see, the simplest possible definition of rest could be a body is said to be at rest when it does not change its position with respect to the surrounding. Right? Write down. Rest. A body is said to be at rest if it does not change its position with respect to the surroundings. Right? So what does it mean? Let us see. Suppose you got a table here, right? Now at 1 p.m. you are at A, which is at a distance of 1 meter from you, right? At 2 p.m. you see you are at the same position. At 3 p.m. also, you see yourself at the same position A. If that means you not change your position with respect to the table, which is the surrounding. Now here the surroundings can in another way be explained as a frame of reference. So surroundings can be understood as a frame of reference. Here the frame of reference is the table. Correct? Here we talk about surroundings, and in that case the frame of reference is the table. It could have been something else depending how you choose it. Correct? Now if we introduce the concept of time as we have already done, let's see how the definition changes, but fundamentally, basically, the concept, the definitions remain same. Only the wordings change, introducing time into it. Let's see. So, after introducing the concept of time, we write rest. A body is said to be at rest if it does not change its position with respect to time. Fundamentally, the concept remains same, but we have rephrased our definition more precisely. Correct? So, we have said that a body is said to be at rest when it does not change its position with respect to the surroundings. Then we introduced the concept of time and said a body is said to be at rest if it does not change its position with respect to time. Right? That was about rest. Now we similarly, in a similar way, define motion. A body is said to be in motion if it changes its position with respect to the surroundings and the term that we used, or a frame of reference. Correct. Now let us see how it changes here. At 1 p.m. you see you are at a distance of 1 meter. Now you come to a position B, which is at a distance of 1.5 meters. Now you come to a position C, which is at a distance of 2 meters. Now see, in 2 hours time, you have moved a distance of 1 meter from the table. That means with respect to time, you have changed your position, which means you are in motion. Now let's define motion in terms of time, with the concept of time included. Let us see. So, again, motion can be defined. A body is said to be in motion if it changes its position with respect to time. Okay, so this is how it looks like when we introduce the concept of time. Now see, the fundamental part is that nothing in this world is at rest. Correct? You might say, sir, I'm standing, I'm at rest. No. Why? Because see, the earth moves around the sun. So the whole earth is moving and you are inside the earth. If the earth moves, you got to be moving also. So rest and motion are relative issues. What I mean by that? Have a look. Suppose this is a field, right? The whole thing is a field. There are two guys who are moving in parallel. They are in parallel, right? And they're moving at 1 meter per second, which interpreted in terms of distance, they each move 1 meter in 1 second, right? Now if they do so, and if they do move parallelly, then see this guy can talk with him, no? They can discuss, converse. So that means what? They are in rest with respect to each other. Meaning thereby, in this case, say this is A and this is B. A is at rest with respect to B, and similarly B is at rest with respect to A. Now see, so you are saying the same thing, they are at rest according to you. No. See, now there is a third guy here, C, who watches you. Now for him, both of them are moving, right? Now the guy C here, the boy C here, sees both of you are moving. So the boy at C watches both A and B are moving. So to him they are moving, to each of them they are not moving. Same thing happens when you are in a train. The train is moving with a pretty high speed. You close your eyes, think, you will see that you think that you are at rest. If you go moving in an aeroplane, even it's better. You close your eyes, think you are at rest. But you are not rest, you are moving at a very high speed. So that is what I said, that motion and rest are relative issues. Correct? Okay. Now, having said that, we come to another quantity called distance. Okay. Let us see what is it. There's a point A here and there's a point B here, right? Okay. Now, if you want to go from A to B, you can go like this, right? You can go like this. You can go like this. And also you can go like this, right? So this is path 1, this is path 2, this is path 3, and this is path 4. Keep this in mind. This is path 4. Now see, the length of P, the length of P3 and the length of the second path are not same, right? So the lengths of P1, P2, P3 and P4 are not same. Correct? That means the distance between 2 points is not fixed. It depends how you choose to move from A to B. Some lazy guy will start from A, go to his friend here, go to his friend here, and then arrive at B. So the distance will be different. Some less lazy guy will go to a friend here and then go. So the distance will be less and the time taken will be less. Okay. Now again for this path 3, same thing. So we can define distance as the actual path covered in moving from one point to the other. So distance. It is the actual path covered in moving from one point to the other. Right? Accepted? So now come to the concept of displacements. Let us see. I talked about path 4. Okay, let's see. So similarly, we've got point A here and point B here. Now we join a straight line. It's a straight line, right? Okay, accept it is a straight line, right? Now see, the shortest distance between 2 points is a straight line. You cannot have it shorter. Okay, so the shortest distance is between 2 points is a straight line distance. So displacement is defined as the straight line distance between 2 points. So let us define displacement. Displacement. It is the shortest that is a straight line between 2 points. So in order to express displacement, you got to say either you are moving from A to B or coming from B to A. Get it correct, right? Now here is a problem. Why? The moment we say from A to B or B to A, we introduce a concept of direction. Now the problem starts with the fact that since we're talking about attaching a direction to a certain distance, we talk in terms of initial position and final position. So displacement will definitely be depending on the initial and final positions of the body. I'll explain. Let us write down. Displacement depend on the initial and final position of the object. The problem of conceptualizing displacement starts from here. What it means, I'll explain. Now see, this is your home, right? Home. And suppose this is your school. Okay, this is school. Okay, whatever they look like, assume they are to be home and that is to be school. Now, the shortest distance between them is 10 kilometers, say. Okay, so you go 10 kilometers, you come back another 10 kilometers in the least. In the least, correct? So the total distance covered is equal to 10 kilometers while going plus 10 kilometers while coming. So 20 kilometers. That's fine. Now where is the problem? The problem is here. See, initially you are at home. That is accepted. At the end of the day, meaning finally, you are also at home. So where is the movement? Where is the distance traveled? No distance is traveled. You go to school and come back. Initial position home. Final position is also home. So the displacement is 0. So get that confusion corrected, right? So the displacement here is equal to 0. Okay. So this is something that is sometimes confusing. Correct? Now in physics, we got 3 kinds of quantities: a vector quantity, a scalar quantity, and a tensor quantity. Now we'll constrict ourselves to 2 quantities, scalar and vector, because tensor is not within the purview of our syllabus or studies at this moment. Okay. Number 1, scalar quantities. Right? What are they? Those quantities which has magnitude only are called scalar quantities. Okay, what is magnitude? Magnitude is nothing but a numerical value. Correct? Which means you can say 10 meters, you can say 10 kilometers, you can say 10 miles, you can say 10 inches, like that. Right? Now what are vector quantities? Number 2. Those quantities which has both magnitude and direction are called vector quantities. Okay. So obviously from this definitions of scalar quantities and vector quantities, we can conclude that distance is a scalar quantity because it does not have a direction. You can go in any direction. But displacement is a vector quantity because, as I said, either you got to move from A to B or you move from B to A. That means either you go right to A or either you come left to A. Right to B and left to A. So attaching a direction. So I think this will have your doubts about displacement, distance clarified. If any questions, please put in the question box. I will answer. And for today, that's all. By the way, I forgot to tell you, you are with Have Fun and Learn, and I'm GP Datta, your host. So, of course, if you like the video, if you like my classes, please give a thumbs up, share and comment, and of course don't forget to hit the subscribe button. Right? Till next class, bye bye.